All right. Last lecture day. Tuesday, we'll be working on review and answering other questions. But today is our last day of lecture. I think this is day 27. And we're looking at prepping for 15.3, which is geometric series. And 15.4, which is the binomial theorem. So the geometric series, we end up having to do a lot of complex fractions, like fractions within fractions. And we want to clean it up. So we're going to practice that. And where this comes up is the formula for the sum for the series is going to be a sub 1 times 1 minus r, not to the end down there, but the n up here, over 1 minus r, and r tends to be a fraction. So we got a fraction in the numerator and a fraction in the denominator. We're just going to focus on this inner part right here because the a sub 1 is just something multiplied by afterwards. We're going to focus on this. So let's practice doing this with a few things. Let's just start off with r equals 1/2. And we'll do like n equals 5. So we are looking at 1 minus 1/2 to the 5th power over 1 minus 1/2. So the bottom is 1 minus 1/2 is just 1/2 on bottom. 1/2 to the 5th power. Two times 2 is 4, 8, 16, 32. That is 1 minus 1 over 32. So what we're going to do at this point is we're going to combine the top. To do that, I'm going to multiply 1 by the denominator we have right there. I'm going to multiply this by 32 over 32. So that I get 32 over 32 minus 1 over 32. And then all of that is over 1/2. So if I clean up the top, because remember this top part, we can make this like 32 minus 1 over 32, combine them into one fraction. And that's going to put 31 over 32 here. All right. Now we want to get rid of the denominator. So what we do is we multiply by the reciprocal of the denominator. I'm just going to flip it. So 2 over 1. And if I do that on bottom, I got to do that on top. what this ends up being is 31/32 times 2/1. Cause this all part cleans up to 1 and we don't need it anymore. That will be 31/16. We know this was 2 to the 5th. Cause that's how we got it. So that'll cancel out, it'll be a power. It's like 2 to the 1st, one of these cancels out with one of those. And we have 31/2 to the 4th, which is 31/16. Or you could have just recognized that 32 is 2 times 16 and cancel the 2 that way. Okay. What's up? What? What's up?
Is the, well, maybe you've answered this, is the final cumulative or just from the midterm onwards?
I'm focusing on the midterm onwards, but let's be honest. Most of the shit on the midterm onwards requires you to know how to do stuff we did in the first half of the class.
But it's just going over like the majority of the topics that we covered.
Right, I might have a few from the stuff before. Just because that way we can balance it out, cause like everything after the midterm, let's say, has been conics, it's been the logarithms and exponentials. And then it's been graphing fucking polynomials. If I make my polynomial and all that, it's just like, why don't I just walk in with a fucking flaming sword, see how many I can fucking kill?
Yes.
You know what I mean?
Yeah, that's what I'm scared about, I don't wanna know, because I'm like thinking, well, what aspect should I study, you know, should I just study from the midterm onwards, or should I go back, you know,
I'll be honest, studying from the midterm onward is the best route to go, because like, you needed the other shit in it.
Yeah, that's really.
You need some algebra skills in it throughout it.
Yeah, I mean, like half the stuff that was on the midterm was the algebra stuff, it was all the review stuff, so. I
Right,
feel like, yeah, we gotta,
so like think about like the polynomials, grabbing the polynomials, you gotta find the roots, which means. Setting an equation equal to 0, so like, we got it down to doing a quadratic, so you gotta learn how to do you gotta do factoring and stuff like that. Use the quadratic formula, or you know, that pulls in a lot of stuff that's already from the past already.
yeah,
So it already incorporates that stuff, but instead of just doing all problems like that, I'll probably have some in there from the first half so that it'll be like effectively a cumulative final. There'll be more problems, but like some of them should be easy.
very cool. And also, AAC people. I'm supposedly scheduled as of right now at Visalia campus to take this test
Okay,
with the AAC, so starting at
on test day,
test.
okay,
I don't know what needs to happen.
I will email the AAC the exam. And tell them how long I'm giving in class, or how long you effectively have. Alright. So. That's the formula we're working on, practicing 1 minus r to the n over 1 minus r. And r ends up being a ratio or a fraction. I want you guys to give it a try with r equals 2/3. And we'll do n equals 4. And you can kind of see what we did with 1/2 and 2. N equals 5. Get yourself some practice. You get this part down, like geometric series is gonna be fucking easy. This is just complex fractions. Which is fractions and fractions, so like people don't like it, but so that's why we're gonna give some practice.
So I have a question.
Yeah,
I mean, the next round of math is the 3D side of things, so it's gonna be a lot of triangles, and unit circle,
yeah,
but I guess calculus is like putting that all together, right? It's kind of how it is,
not really.
not that it's totally a different.
Yes, completely different thing.
Calculus goes and videos and some studying more like motion and movement.
Well, that's a common use for it. Physics is a common outlet for it. It's more like parts of it are calculating the area underneath the curve.
Right.
So calculating weird areas. And then that's like the second half. The first half is finding the slope of a tangent line at any point. So a tangent line just touches it at one point and that's it.
Yeah, I was gonna say, I'm like, that, I can see the tangent line in the big deal. Because it's colliding objects.
Well, it also gives us a relationship between, like in physics, position, velocity, acceleration, jerk. Mathematically, they're all derivatives of each other. Which is kind of neat. The derivative of position is velocity, derivative of velocity, and that's the first thing you do is derivatives. Derivative of velocity, acceleration, derivative of acceleration is the jerk or change in acceleration.
I feel like there's something there, but so then it's emotion. Very good. It's- Something like, but that's like the highest level. For gas expansion. Crazy stuff. Like we do. Wow. Well, I mean, I wanna say nuclear radiation is where we're at right now, that's true. For half-lives is like this level of stuff,
We did half-life in here.
yeah, they could say, we're at. So you can do a lot of the radioactivity work with what we have,
Yeah.
but. Well, like, we just kind of watch, you think it'd be way down the line, but it's actually, we already know how to do that right now. But I'm like, so we're close, I guess. I'm like, that's the.
It turns out finding the area underneath the curve and the derivatives has uses across the fields. Like economics it has uses for, physics it has uses for, engineering being like weaponized physics, basically.
Yeah.
Engineering clearly has a use for it. A lot of fields have a use for calculus. It's used to do all the equations for magnetism. It's used to do all the equations that have like energy and electricity. It's used for fluid flow. So like water, air, plasma, blood. So you can like model the flow of blood in an artery. And do the math, it's called biomathematics. There's a field, how to apply mathematics to making better tech shit for the medical field.
That's the big, I've been doing research on like some of the stuff I've been after. And
Right.
it's been interesting.
Did everyone do this?
Yeah.
What'd you get?
15 over 27.
Let's find out. That doesn't sound reduced, but let's check it out. Did you get that? You didn't do it, you've been talking the whole time.
I've been talking.
Alright. So let's plug it in. We got 1 minus 2/3 to the 4th power over 1 minus 2/3. The bottom. I can turn this into 3/3. So 3/3 minus 2/3 is 1/3. We really need to figure out that 2/3 though. This is 2 to the 4th power over 3 to the 4th power. Which is like 2 squared times 2 squared over 3 squared times 3 squared. Is a little bit easier way for most people to see it. 4 times 4 over 9 times 9 is 16 over 81.
Well, so question with this, would it be wise for us to get that 1/3 out of the bottom by multiplying by 3? Isn't that
We're
basically-
going to,
Oh, well, I guess that's what we could just be about.
you need to clean up the. It's much easier if you clean up the top, because otherwise you're gonna fuck up and do distribution wrong or exponent wrong. It's much less error prone to.
Common mistake, I forgot to, I just subtract the, I just subtract the top, that's, I didn't, do the, multiply both, sides to make the fraction. Yeah. Forgot to do that.
So we have 81 minus 16 over 81 over 1/3. Let's see, 81 minus 16 is that 65?
Yes.
And now we're gonna do what Davis was asking about, which we showed doing up here. You multiply by the reciprocal of the bottom. So we got 65 times 3 over 81. Well, 81 is 9 times 9, and 9 times 9 is 3 times 3. So that 3 can cancel that 3. And I have 65 over 9 times 3. Does it clean up more?
No,
Yeah.
This is
No.
13 times 5 on top. And this is 3 cubed. So there's nothing in common. So it looks like the simplest it goes is 65 over 27. Now, if you'd have gotten that this one would clean up more, because you could see that they're both multiples of 3.
yes.
All right. Let's have some fun with it. Let's give you another one. I'll rewrite the equation again.
And R means radius here, or?
Ratio. It's the ratio of 2 consecutive terms. Yes, you know how when we were doing, we had multipliers?
Yeah.
Well, if you divide one by the other, you're gonna have the same one multiplier pops out each time. That's the ratio. Let's do. -3/4. Dun, dun, dun. Yeah, let's do n equals 3. This is keep the numbers smaller.
That's not like,
4 isn't too bad.
it could be worse. It could.
At least try it. It's just a fraction. That sucks about your car, James.
Real. I don't know if you can hear me right now because I don't know
I
if
can.
okay, cool. But yeah, shit sucks.
Hopefully it's not something too expensive to fix.
Yeah, I already got my it's a good thing you got buddies that are, like mechanics and shit.
Oh, fuck yeah.
So that's free maintenance right there. Plus my cousin, chilling. He's already looking at
Nice.
it right now.
Awesome.
Yes, sir.
Yeah, my father-in-law does he worked at the prisons doing like air conditioning and shit like that, but he was like a all-around maintenance, so like he's getting older now, but he makes a good supervisor. When we need something done around the house, David doesn't do it. David calls dad.
The buddy that I got working on my car, he actually like literally today got his certification to work on car air conditioners. So that's kind of
Nice.
a coincidence.
Are you done, Keith?
I think it's 91 over 32.
Write that down. I don't know what it is.
I think it's 91 over 112.
112. So that's another option. Anyone online get an answer? I'm not hearing responses.
Everybody's arguing about.
Right. Yeah.
I thought it was,
I'm bad. I fucked up I fucked up some people there.
So
That turns into a plus, doesn't it?
because it's plus 3/4.
4 over 4 plus 3 over 4. On the bottom, we're gonna have 7 fours.
It is a cheap.
Here, we're gonna have minus. This ends up being negative 27 over 64. So that's gonna be a plus as well. We're gonna make this 64 over 64. So when I add those together, I got 64 plus 27 is 91. I see the 91. That's a good sign. I like what I'm seeing. So we'll multiply by the reciprocal of the bottom.
Can you do it not reciprocal and do it in stages, like do multiply by 1/7 and multiply by 4 separately?
Yeah, you want to take it slow.
It's the same.
That's effectively doing,
Yeah. You do it side by side, it's.
so I've got 91 times 4 over 64 times 7. 91, let's see, that is 7 times 13, isn't it? 64 is 8 times 8 or 4 times 16. It looks like this simplifies to, let me make sure, 7 times 13, I got 70 plus 21 is 91. This simplifies to 13 over 16. If I divide 7 into 91 over 12. That's gonna be 13 on top. 70 and 42 is 16, so 91 over 12 was the right value, but the wrong answer. So close.
I just saw 91 and thought that was odd, and I was like, kind of like it was prime.
Right, it's one of those higher ones, you're like, I don't know any values of it. So the real question there is like, what do I do here? So like, I know. Does the 91 simplify? So without looking like at the right side here, let's cover that up. I want to know if the 91 simplifies. 64, this is 8 times 8. This is 2 cubed times, this is all 2's. 91 is odd, so it's not divisible by 2. So the next question is 91 divisible by 7? That's where you just check it. And so that's where I like, that was my thinking, I didn't say it out loud. And I read, like, in my head, I go, is 91 gonna cancel the 7? And so I was checking in my head doing this stuff. But that's what you should do to check to simplify. Don't go through all the list of fucking numbers and go, what are its prime factors? Just go, what on the bottom could possibly divide into it? You know what I mean? Because we don't need to check all of them, we just need to check a few. It's called working smarter, not harder. Alright, so that was some fun shit there. Another one that you're gonna love. It comes in parentheses like that, with n like that, and r like that. This is n factorial over n minus r factorial times r factorial on bottom. This shows up in 15.4. It is not the easiest way to do 15.4. We're going to do it another way, but this does show up a lot in statistics. So like it's worth knowing how it works in case you ever take a stats class. You'll have some practice with it. Or if you don't like doing Pascal's triangle, which I'm gonna just give you an F now. Yeah. It's not on the test, but Pascal's triangle is like magic. It's fucking magic. Let me get some equations for this. Fuck it. I don't need equations. Just pick some sample numbers. Davis, give me two numbers. 2 and 7. N needs to be bigger, so I'm gonna say 7 and 2. So this is 7 factorial over 7 minus 2 factorial times 2 factorial. And we talked about working smarter yesterday. Let's just get this down to the biggest factorial on the bottom. And I'm going to do 2 factorials, 2 times 1. And 5's cancel, 5 factorials cancel. And 6 is 3 times 2, so the 2 cancels. Leaves everything I cancel out, leaves behind a 1. On the left with 7 times 3 on top, 1 on bottom. This is just 21. When you see this, this is read as N choose R.
Yeah.
Yeah.
Said, yes, statistics.
This is in combinatorics. And it made me a lot of money in the last couple of years.
Really?
Casino wanted some help. They wanted to make it, they were, they do like, there's slot machines that have progressive slots. They wanted to do something similar with card games. Like do a progressive card games where like you have to get a certain specific hand with enough rarity that it only happens like once every 6 months or once every 3 months or something like that. And so they knew about how many hands, each table game, about how many hands they played a month. And so how many hands were played over the time period. And I needed to calculate, like they wanted to know what hands would strike only maybe once every 3 months. If let's say 80,000 hands are played a month. So like, and then there's different card games like Hold'em and shit like that. There's a lot of math, but you can do a lot of N choose R. Yeah. Yeah.
I don't know if I just like missed it, but where did the 6 and the 5 come from?
So factorials. The 7 factorial is defined as 7 times 6 times 5 times 4 times 3 times 2 times 1. So I just put this back into factorial form and did that. So what's the probability? We'll do it again, like we'll talk about it real quick. What's the probability of getting pocket aces in Texas Hold'em? So. What you need to know is you're dealt 2 cards face down. And we're trying to say, what's the probability this is an ace and this is an ace? You need to know there are 52 cards in a deck. You need to know that there are 4 of each rank in a deck. So which means there's 4 aces. So applying N choose R here is like, how many ways can I draw 2 different aces out of 4? Because each different combination counts as something different. You have hearts, you have diamonds, those are the red cards. You have clubs. And you have spades. That's not spades, spades is like that, there we go. Spades and clubs. So 4 suits, 3 each different, so like the ace of hearts and the ace of diamonds is one combination. Ace, we can like go through and write them out. You can technically write them out. In fact, I'll do that real quick. We could have heart diamond, we could have heart, I'm gonna say heart club, heart spade. Cause those the black ones take are a little bit more work to draw. Then I could do diamonds with everything. Diamond already has the hearts. So we could have diamond club and diamond spade. And we could have club and spade. So there's really only 6 ways we could draw 2 of the aces, assuming the order doesn't matter. So it turns out N choose R, there are 4 aces and we are choosing 2 aces. So we're doing 4 choose 2. So this will be total number of aces, or no, total number of pocket aces. Total ways of making pocket aces. So we've got 4 factorial over 4 minus 2 factorial times 2 factorial. This is simple enough. I get 2 factorial and 2 factorial. The 4 just cancels with the 2's on the bottom. I'm left with 3 times 2 is 6. 6 ways to make pocket aces, that's not probability though.
6, but that's 6 ways to make populations out of the.
How many ways can we draw 2 cards out of 52? That'll give us the bottom part of the fraction.
That would be 6 different combinations of the 2 aces, like the 6 possible.
6 possible combinations of drawing 2 aces out of the 4. Where order doesn't matter. If order matters, it's called permutations, and that actually it's almost the same formula. You just don't have the r factorial at the end. It's just n factorial over n minus r factorial.
Are you doing this statistics class or no?
Not this semester, but next semester, summer I got them in.
So
I've got 3 in summer and
I've got a really old watch statistics class that I need to get redone. And I'm hoping that they'll take it. It's from Oral College, it's C though, so it's like. Maybe an argument.
let's talk after class. How many ways to draw 2 random cards out of 52? I'm not drawing the 52 all the combinations. There's a lot.
Yeah, there's a ton.
I don't know that I could do it on a single piece of paper.
Yeah, that's one.
So we're just gonna do 52 choose 2.
There'll be like 2 specific aces.
Fifty factorial, this is 50 factorial times 2. The factorials cancel. And I'm left with 52 times 51 over 2. which is 26 times 51. Which is. 1,326. So the total ways of drawing two aces. With with the first two cards. Over the total ways of drawing two cards will give us the probability.
Oh, so this is the counting cards thing, because if you know how many hands you can play out of the deck before you shuffle them.
Not really.
No.
Cause Texas Hold'em, they shuffle them every time.
Yeah.
It's more of a, that's more of a blackjack thing. And it's based on shit like this, but like something different. I've got 6 over 1,326. Oops. Which is, oh shit, I need that fraction already.
We get to.
This is 0.0045249, and I'm rounding there. It keeps going. In terms of a percentage, this is 0.45%. That's what you're saying.
Yeah.
Hey, Jones.
That's me all day long.
So we kind of did, because I took statistics last semester, right? So we kind of did something like this, but we did it like because there's 4 aces in a deck of 52 cards, right?
Mhm.
So you get 4 over 52 and you multiply that by, if you were to get 1 ace, you would have 1 less, and there's 1 less card, so 3 over 51. And that gives you 1
Another
over
way of doing
2.1.
it.
That's another way of doing it?
Yeah, that is a valid way of doing it.
Okay, I see.
But it wasn't related to N-choose R. That was what my topic was on, so I didn't go that route.
Yeah, okay.
So what he was saying is, on your first card, there's 4 aces out of 52 cards in the deck. And on your second card, assuming you've already drawn an ace, there's only 3 aces left, and there's only 51 cards left. So this is 12 over 52 times 51. 12 is 2 times 6. When this gets down to 6 over 26 times 51, and we just saw the 26 over 51 there. And the 6, so you get the same shit. I actually like this way better. But it wasn't related to N-choose R. But you can do N-choose R to do it, and N-choose R for what I did for the casino was a hell of a lot easier than doing this. Because it was more of a, we're not like, it wasn't how many ways to just draw 2 aces. It was how many ways to get a fucking straight. Out of 5 cards out of 7. It's not a fucking trivial thing. You know,
Yes.
because you get 7 cards in Texas Hold'em. You gotta make it straight. And you don't want to include straight flushes in the straight. And you don't want to include royal flushes in the straight because they are higher.
Oh, yeah, I was gonna say they're not just straights, yeah.
Yeah, so if you got them, they're better than the straight. Yeah. So you don't want those. I want to show you Pascal's triangle real quick. This is because the equation, oh, fuck it. I'll just show you the equation right away. This is the equation that has the N-choose R. It looks fucking messy as fuck. We are going to do that x to the n and x to the n minus 1 y, and then x to the n minus r y r. But like If you've got n is really high, you've got to do this for a whole bunch of you gotta do n choose r for a whole bunch of different things right here. And Pascal's triangle is really easy. And it gets to the same coefficients. And I'm gonna do it again later, but we got 5 minutes left and there's no point throwing another n choose r at you when you're probably not gonna use it. So you're literally making a fucking triangle. You don't need the like the lines here, but I'm kind of like doing it to show it. You got a 1 at the top. The next row you have 1 and 1. So the ones are going to go down the sides.
Yeah, and what is being modeled here mathematically? Like, that's the thing. It's always-
These are the coefficients to the binomial theorem. A plus b to the nth power. This corresponds to n equals 0. This corresponds to n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6, and the triangle keep it getting bigger. What you do to fill out the inside is basic arithmetic. You take the two numbers above it and you add them together. 1 plus 1 is 2. One plus 2 is 3. 2 plus 1 is 3. If I add the 1 and the 3, I get a 4 here. 3 plus 3 is 6. 3 plus 1 is 4. 5, 10, 10, 5, 6, 15, 20, 15, 6. You're looking, this is like the binomial theorem. So these are the coefficients. What you do as you write them is we start off on the left side with a to the n, b to the 0. And as we go to the right, this goes down by 1 and this goes up by 1 each step until you get all the way down to where a is 0 and b is n. So like, let's say we're doing a plus b to the 5th power. I'll just write the a's and the b's for now. We will have a to the 5th power, b to the 0. A to the 4th power, b to the 1st power. A to the 3rd power, b to the 2nd power. A to the 2nd power, b to the 3rd power. A to the 1st power, b to the 4th power. And a to the 0, b to the 5th. That's all those things. N equals 5. I'm going to take those and drop those coefficients in. So if you clean it up, you won't write the b to the 0. We've got a to the 5th power plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4th power plus b to the 5th power. You could take these and multiply them out because this is a plus b times a plus b times a plus b times a plus b 5 times. And you could multiply them out and you will get that. And so like there's a formula for doing the shortcut for it. It's pretty easy to do, it's pretty easy to remember, and there's nothing complicated in it, it's arithmetic and subtraction. That is literally all that's involved.
So so you could do this with, like you could swap A plus B out with X plus one.
Yeah, we will today.
Uh,
So like when we have like one of them's a number, well, then we're not gonna leave it as like the number cubed, we're gonna do it and then,
Right, find out what it is.
yeah. Right. And it works with negatives in there. It turns out if you have like A minus B, the first one's positive and the sign alternates. Basically because of the exponent thing, but it's kind of cool. And that's called Pascal's triangle. We'll use that today. And this is rather than doing n choose r for these coefficients. You would have to do. Look at this.
I don't keep bothering you, I got you.
Angel, my man, thank you, sir.
Yeah, of course.
That's respect, thank you.
Love to.
He took me to get stats with me.
Oh, really?
Yeah.
Oh. That's how good it is. Wow. Let's feel really good. How those teachers.
That was way better than a T. That kind of shit just makes my day. It makes fun, let's be honest, if you just stopped by and said, hey, Mr. Jones, that makes my day too. But this makes it even better.
I just trip out whenever, I remember this form being shown Pascal's triangle a lot of times, and no one ever knew what it was used for. And I'm like, and I'm just like, oh, it's for this, no way.
It's fucking magic.
It's for this.
Is there like something like history behind the
So the guy that came up with it. His name was Blaise Pascal, he's French. I believe he's French. That's all I got. It was a long time ago.
Yeah, we've had read like full companies. But I'm like, but yeah, it's a thing, he's one of the.
Yeah, he is French.
early thinkers, and
And that's all Mr. Blakely has in here, is he was a French mathematician.
That's it. He's like.
That's all I got written down.
There's more, with all of them, there's a bigger story, like all of those names have like a much broader story, if you look, it's crazy.
So when you're doing the Pascal's or when you're doing the n choose r. The middle terms are like a to the n minus r, b to the r. And then you have the n choose r there. So like you can see like when we got a to the fourth, b to the first, we've got 4 choose 1. Here we've got 3 choose 2. And it ends up being going down the line like that.
Pascal's weak, same guy,
Pascal's what?
Pascal's weak. Yeah, it's old, very good, it's old, he was a Catholic writer, that's how I pretty say. But that's the same thing, it's R, it's n choose R. Expressed in this pattern. So what if, so you could use this, so let's say. So what we're saying is that if I've got x plus 1 to the 5th. And I've got -1 repeated 5 times. As a root or whatever.
Like x minus 1 or x?
Or x minus 1, maybe.